Today we're doing chapter two, starting on chapter two. So this is 2.1. Um, this chapter is about equations and inequalities. Um, and I think the best way just to go into here is to do some examples. And what we're doing is basically solving for, well, at the beginning we're solving for x, and then we'll try to solve the equation not for x, but just to solve it like for certain variables. So x could equal b, y, or something like that. So that you'll see what I mean. So for our first example, we're just going to do a simple one. So 5x minus 3 equals 12. And the first step here is to simplify. It's really simplified. You can't really add any x's together or add any numbers together. The second step is to isolate the variable term. So we want to get this variable by itself. And the way to do that is, you see this -3 here. If we add -3 to both sides, like what you do on one side, you gotta do the other side. This turns out to be nothing. And this, it turns out to be 15. So now you have, I'll rewrite it down here, 5x equals 15. Now, I just did the opposite of this sign to get the plus. If it was a plus sign, I would have done negative. I would have subtracted it out both sides. For this, to get the variable by itself, we need to move this 5. And this is 5 times x. That's what it literally means. So to undo multiplication, we do division. So we would divide this by 5. Both sides. Can't do what one side, you got to do it the other side. These two cancel out. And this, well, let's do it like this. So those two cancel out. This is x equals 15 fifths. Now 15 fifths, 5 will go into 15 3 times. So the answer is x equals 3. We can check our work. We know that x now equals 3. So if we plug in 3, so this was 5x. Now we're just going to say 3 for x minus 3 equals 12. So now we have 5 times 3, which is 15, minus 3 equals 12. And that is just 12 equals 12. So it checks out. That's our first example. I'll clear the screen. Our next example is 2/3, and that's a 2, x minus 4 equals 1/4 x plus 6. Now, there's two ways you can do this. We can do it with the fractions, or we can eliminate the fractions. And eliminating them may make it easier for us. So let's do that. Basically, for these fractions, we want to find the LCD for both of these. And I know by looking at them, the best LCD I can come up with is 3 times 4, which is 12. So that's basically what we're going to do is we're going to multiply 12 into each side. What you do to one side, you got to do to the other. And then we'll just use distribution to get rid of the fractions here. So 12 times 2/3, you can think of it as 12 over 1 times 2/3. This would be 24/3. But 24/3, 3 goes into 24 how many times? Yeah, I believe it's 8. So this would be the 12 times 2/3 x would be 8x minus 12 times 4, which is just 48, equals, all right, 12 times a quarter. You could do the same thing. I mean, if you know just a quarter of 12 is 3, I mean, you would know that, but that's okay. We'll do it this way. This equals 12/4. And 4 going 12 times, 3 times. So this is 3x plus 12 times 6. And that's just 72. Now we've simplified it. We need to combine or get the variable on one side by itself. So there's several ways you could work this, but I just choose to move the 48 over first. And so this equals just 8x equals 3x plus 8, 9, 10. We could do it this way. 7, 8, 9, 10, 11, 12, 120. And I was just adding there. Now, to get this x over to here, what should we do? Oh, excuse me. Do we multiply or do we divide or do we subtract or do we do addition? Think of it like this. This one has a plus sign understood in front of it. We just want to move it over here. We're not breaking multiplication. We're breaking addition. So we just do subtract. This turns into 5x, and this turns into just 120. Now, to break multiplication, we're going to use that division again for both sides. That 5 goes away. This is x equal to, we'll go ahead and do the division here. 5 will go to 20, 120, 24 times. And that's the answer. We could check this. It's not too hard to check. 2/3. We figured out x is 24. 24 minus 4 equals 1/4. 24 plus 6. So what we do here is we just solve both sides. And if they equal each other, then we're good. So 24 2 will go in 24. That's 48 thirds. So I'll just write it down that way. 48 thirds minus 4 equals 24 fourths. So we're multiplying, remember? Multiplying right here. Plus 6. So 48 thirds. All you got to do is get your calculator. It's easy. 48 divided by 3. And it's just 16. 16 minus 4 equals, now 4 will go into 24 how many times? That's just 6 times. So 6 plus 6. So 16 minus 4 is what? 12 equals 6 plus 6 is 12, and those are equal. Check out. Let's do yet another example. A fun example here. We have 0.3x, and we're subtracting it by 1.7. And we're setting that equal to 0.007 x, and we're subtracting that by 4. Now, there are ways to simplify this. I'm not a big fan of needing to simplify decimal points. I can show you both ways if you like, but uh, okay. Let me show you the book's way, and I'll show you the other way, and I'll show you how you can get to the exact same answer. Because in the day of calculators, you don't have to pull this stuff out. All right. So the book's way is to say, okay, we know that this is in the and I wrote this incorrectly. This is awesome. Let me just remove this 0, or heck, I'll just remove both for fun. And then we'll add 1 0. And that's in the hundreds place. Tens, hundreds. This is in tens place. So since that's in the hundreds place, let's just multiply both by 100 to get rid of that decimal. 0.3x minus 1.7 equals 100.07 x minus 4. Now, if you do distribution here, you'll be left with a this okay. So 100, you're just adding zeros here, so you're pulling it out of its point with zeros. So 100 times 0.3x is 30x minus 1.7. And this side, because it's 0.07, this is just 7x minus 4. And you can do these on your calculator too. 100 times 0.07, you'll get 7. So, okay. And then solving this is pretty straightforward, just like our other ones. We just move our, excuse me, we move our, huh, well, I may have made a slight mistake here. It's interesting because I didn't even, I'm thinking forward to, doing it without having to move this 100 in front of it, because now you get the situation where you have these large numbers. So this one would actually be 170 because that's 100 times 1.7. And 100 times 4 is actually, 400. So you do get these large numbers. but they are regular integers, and maybe it is easy to think about and work with. Um, but for now, I'm just going to add 400 to both sides.